The Persian Gulf has been mined before. It was mined during the Iran-Iraq War, when Iranian naval forces laid contact mines across commercial shipping lanes, with a systematic patience that produced results disproportionate to the cost of the weapons themselves. The USS Samuel B. Roberts struck a mine in 1988 and nearly sank. Not because the adversary had brought overwhelming force to bear, but because a single cheap weapon placed precisely in the right location produced structural damage that required months of repair and permanently altered the risk calculus for naval operations in the Gulf. The lesson from that event was recorded, studied, and incorporated into the mine countermeasures doctrine that the U.S. Navy carries to this day. The lesson was never forgotten. What was harder to fully incorporate into doctrine was the lesson about timing. The Samuel B. Roberts was operating in an environment where the mine threat was known in a general sense. The Gulf had been mined, patrols were ongoing, the threat was present. What the crew had not known was the specific location of the specific mines in their specific transit corridor. General awareness of a threat is not the same as specific knowledge of a threat's exact position. And in the gap between those two states of knowledge, mines exercise their particular form of strategic patience. The mine threat in the current operating environment had been elevated in the collection reporting for 11 days. Satellite imagery had identified Iranian mining vessels, surface craft capable of deploying moored contact mines and influence mines, operating in the central Gulf during a series of nighttime transits that imagery could track, but not fully characterize. The vessels had been in areas consistent with mining operations, but the specific locations of any mines they might have laid had not been confirmed by any collection method with sufficient precision to plot individual mine positions. The mine threat was assessed as real. Its specific geography was unknown. The destroyer had transited the central Gulf corridor on 3 occasions in the preceding 2 weeks without incident. The 4th transit began at 10:15 p.m. The route was the established commercial shipping lane, the same lane used by hundreds of vessels per week, the same lane that the previous 3 transits had used without contact. The mine threat assessment had been briefed. The navigational watch had been placed on heightened alert for any anomalous surface or subsurface contact. The ship's hull-mounted sonar was in active search mode. The route was the same because the route had been clear, and because diverting from the established shipping lane in the absence of specific intelligence about a specific location would create its own navigational hazards in the dense commercial traffic environment. At 11:38 p.m., the forward sonar operator reported an anomalous contact, not a dramatic report. A measured professional observation that something in the sonar return ahead of the ship's track did not match the ambient characteristics of the seabed return that the system had been processing for the previous 83 minutes of the transit. The contact was small. It was approximately 40 meters ahead of the ship's bow. It was stationary. It was at a depth of approximately 9 meters below the surface in water that charted at 14 meters. At the ship's current speed of 12 knots, 40 meters ahead was approximately 6.4 seconds of travel time. The officer of the deck ordered all stop and reversed engines simultaneously with the sonar operator's report. The reverse thrust engaged in the time it took the order to travel from the bridge to the engine room, and the throttle response to register in the propulsion system. Approximately 3 seconds. The ship's forward progress under momentum continued for approximately 61 meters before the reverse thrust arrested the forward motion. 61 meters past the position where the order was given. 21 meters past the estimated position of the sonar contact. At 12 knots and a contact 40 meters ahead, the full stop order had been approximately 6 seconds too late to prevent the ship from passing over the contact's estimated position. The ship did not strike anything. The contact had been either a false return, a piece of subsurface debris, or a moored mine whose position at 9 meters depth placed it below the keel clearance of the destroyer at that draft in that water depth. The damage control teams reported no hull impacts, no flooding, no unusual vibration. The ship was intact, but the sonar operator's next sweep, conducted with the ship now motionless in the shipping lane, produced something that changed the character of the situation entirely. Not one contact, multiple contacts. The sonar picture, with the ship stationary and the propulsion noise no longer masking the ambient returns, showed a pattern of small, stationary subsurface contacts distributed across the navigational lane ahead of the ship's position. The operator called them one by one as the processing system discriminated them from the seabed clutter. 4 contacts within 200 meters of the ship's bow, 7 more within 500 meters ahead. The pattern was not random. The contacts were distributed in a deliberate spacing geometry, offset from each other by approximately 35 to 40 meters in the cross-lane direction, creating a coverage pattern that left no clear gap wide enough for a ship of the destroyer's beam to transit, without passing within the influence radius of at least one contact, a minefield. Laid in the established shipping lane during one of the nighttime transits the mining vessels had conducted in the preceding 11 days. Laid specifically in the route geometry that U.S. naval vessels used most frequently, at a contact density that the spacing analysis was beginning to suggest covered at least 800 meters of the forward transit lane. The commanding officer had been on the bridge since the initial sonar report. He now had a set of facts that defined his operational situation with uncomfortable clarity. The ship was stopped in the middle of an active shipping lane with a minefield of unknown extent ahead of it. Commercial traffic was continuing to move through the lane from both directions. The nearest southbound commercial vessel was approximately 3 nautical miles astern, its navigation lights visible on the horizon, moving at a speed that would bring it to the destroyer's position in approximately 14 minutes, unless it received a traffic warning and diverted. Northbound traffic presented the same problem from the opposite direction. The first call went to 5th Fleet to report the mine contact and request mine countermeasures support. The second call went on the commercial maritime distress frequency, warning all traffic in the vicinity of the shipping lane of a hazard requiring immediate diversion. The third call, Nantorise, and the stalk call, the fall that would define the next 4 hours of the engagement, was to the ship's own operations center, where the commanding officer ordered the helicopter to be brought to immediate readiness for mine hunting operations. Mine hunting from a naval helicopter is not the primary mission for which the MH-60 is designed. It is, however, a capability that the platform's sensors, specifically its dipping sonar and its forward-looking infrared system, can contribute to in a surface minefield environment where the mines are moored at relatively shallow depth in calm water. The dipping sonar could provide acoustic characterization of the contacts the hull sonar had detected. The FLIR could detect the mooring cables of shallow-set, moored mines if the water clarity and the ambient thermal differential were sufficient. Neither system would provide the precision of a dedicated mine countermeasures vessel, but the ship did not have a dedicated mine countermeasures vessel. It had a helicopter and a hull sonar and a crew that understood the problem. At 11:54 p.m., the commercial tanker that had been approaching from the north, a fully loaded vessel carrying approximately 1.4 million barrels of crude oil and transiting at 15 knots on the established southbound shipping lane, responded to the distress frequency warning. The tanker's master requested clarification of the specific hazard location and asked for navigational guidance for an alternate route around the threat area. The problem was that the ship's crew did not yet know with sufficient precision where the minefield ended. The sonar picture showed contacts extending ahead of the ship's position, but it did not show the eastern and western boundaries of the field, and it did not show whether the field extended astern of the ship's current position, whether the ship had transited part of the minefield to reach its current location without triggering a contact, or whether the field began at the ship's bow position. At 12:06 a.m., the electronic warfare system registered emissions from the Iranian coastline to the north, fire control radar. The bearing placed the emission source at a coastal position approximately 41 nautical miles north-northeast, a range consistent with a Noor anti-ship missile battery's effective engagement parameters, and a position that the system's database matched to a battery site that had been inactive in previous collection reporting. The minefield and the coastal battery were not coincidental. The minefield had stopped the ship. The coastal battery had been waiting for the ship to stop. The mine deployment and the coastal battery activation were components of the same operational design. The minefield as the immobilizing element. The coastal battery as the exploitation element that would engage the stopped ship before it could extricate itself from the mine barrier or maneuver to defeat the missile threat. A stopped ship in a minefield is a ship that cannot maneuver. It cannot run from a missile threat. It cannot present a changing speed and bearing to complicate a fire control solution. It cannot execute the evasive maneuver that is a stopped ship's only viable response to an inbound anti-ship missile. It can fight in place, using its own interceptor systems, but the geometry of a stopped ship against an inbound sea-skimming missile is fundamentally more demanding for the interceptor systems than the same engagement against a maneuvering ship that is presenting a continuously changing target geometry. The IRGCN planners had understood this. The combination had been designed precisely to produce this situation. The TAO called the engagement Fire Control Radar Active bearing 023, classified Noor battery. Authorize SM2, outer ring. But the SM2 authorization presented its own problem. The ship was stopped in a minefield. Any change in the ship's position, forward, backward, lateral, risked contact with the mines that the sonar was tracking in the water around the hull. The ship could not maneuver to improve its weapons employment geometry. It could not change course to present a more difficult target to the coastal battery. It had to fight from the position it was in, with the weapons systems oriented as they were currently oriented, against a threat that was approaching from a bearing that placed it in the forward starboard arc. A geometry that was adequate for the forward VLS cells, but less optimal than a maneuvering ship's engagement posture would allow. The launch came at 12:07 a.m. and 18 seconds. 2 contacts inbound from the Noor battery bearing, their sea-skimming profiles visible on the Aegis radar as they cleared the Gulf's surface radar horizon at approximately 53 nautical miles and began their terminal approach. The flight time at that range, approximately 6 minutes and 20 seconds. 2 interceptors launched from the forward VLS cells at 12:07 a.m. and 41 seconds, 23 seconds after the launch detection. The delay attributable to the fire control solution build and the authorization sequence. The SM2 launches produced the characteristic hull vibration that transmitted through the ship's stopped frame without the damping effect of forward motion. Felt more sharply throughout the hull in the absence of the propulsion and water flow noise that normally accompanied a launch from an underway ship. The helicopter had been launched at 12:03 a.m. on its mine reconnaissance mission and was now operating ahead of the ship's bow, its dipping sonar building a more detailed picture of the minefield geometry. At 12:07 a.m., the helicopter crew received the threat warning from the CIC and was directed to clear the engagement area and hold at a safe range while the missile intercept was resolved. First SM2 intercept confirmed at 31 nautical miles. Second SM2 intercept confirmed at 28 nautical miles. Both Noor contacts eliminated in the outer ring engagement. The Noor battery fired again at 12:09 a.m. and 4 seconds. Ooh, not 2 missiles this time. 4. The second salvo was larger, the battery committing its full remaining ready inventory in a single salvo, the operational decision to escalate the attack now that the first salvo had failed to produce a result. 2 additional SM2 interceptors launched from the forward VLS cells. ESSM cells armed for supplemental engagement. The fire control system managing 4 simultaneous intercept solutions from the stopped ship's fixed position. The Aegis processing load elevated but stable. The combat systems officer watching the thermal indicators with the same attention he devoted to them in every high-intensity engagement. 2 SM2 intercepts confirmed. The leading 2 contacts of the 4-missile salvo, eliminated at 33 and 30 nautical miles respectively. 2 contacts remaining. The fire control system transitioned to ESSM engagement for the trailing 2 contacts of the salvo. 2 ESSM interceptors launched. First intercept at 18 nautical miles. Second intercept at 15 nautical miles. All 4 second salvo contacts eliminated. At 12:10 a.m. and 51 seconds, the electronic warfare system showed the Noor battery's fire control radar emission ceasing. The battery had expended its ready missiles. Whether it would be able to reload and re-engage was a logistics question that the commanding officer did not know the answer to. But the cessation of the fire control emission provided a window, a period in which the immediate missile threat had been addressed and the ship's full attention could return to the problem of the minefield. The helicopter returned to mine reconnaissance operations at 12:11 a.m. Over the next 47 minutes, its dipping sonar and FLIR built a picture of the minefield's geometry that was sufficient to identify one navigational corridor, a gap approximately 90 meters, on the lane's eastern edge, where the mine spacing appeared to be wider than in the central lane, possibly reflecting a positioning error in the original mine deployment or a deliberate gap intended for the mining vessel's own use. The gap's position and boundaries were transmitted to the CIC's navigational picture. Before the commanding officer issued the transit order, he spent 4 minutes reviewing the helicopter's sonar picture with the navigator and the combat systems officer. The picture was not clean. Sonar in shallow water with a silty bottom. The Central Gulf's seabed is not the acoustically ideal, hard-bottom environment that produces the sharpest mine returns. Produced contact classifications that ranged from high confidence to ambiguous. Of the contacts in the identified gap corridor, 3 returned classifications. The operator rated as probable seabed debris rather than mine objects. 1 returned a classification. The operator rated as uncertain. The acoustic signature was not definitively inconsistent with a moored mine, but it was also consistent with a large piece of subsurface debris, possibly a section of old pipeline material that the Gulf's commercial infrastructure history made plausible. The uncertain contact was positioned approximately 60 meters into the gap corridor, 20 meters to the left of the centerline path that the navigator had plotted as the transit route, 20 meters to the left of a ship that was 12 meters in beam, leaving a lateral clearance of approximately 14 meters between the edge of the ship's hull and the uncertain contact's estimated position. 14 meters, if the contact's position estimate was accurate. Sonar position estimates in shallow water silty environments carry a position uncertainty of plus or minus 3 to 5 meters at the ranges involved. The commanding officer looked at the picture for the 4 minutes available. He looked at the uncertain contact. He looked at the alternative, remaining stopped in the shipping lane while the mine countermeasures assets traveled their 8 to 14-hour transit from the nearest available platform, during which the Noor battery's reload cycle might complete, during which commercial traffic disruption would compound, during which his ship would remain a stopped, fixed position target in a contested body of water. He ordered the navigator to offset the transit route 4 meters to the right of the original center line, increasing the lateral clearance to the uncertain contact by 4 meters. It was not a large adjustment. It was the adjustment that the geometry permitted, while keeping the ship within the identified gap corridor's boundaries. Then he ordered the transit. The commanding officer made the decision to attempt the transit through the identified gap, accepting the residual risk that the sonar picture might not have detected all contacts in the gap corridor. The alternative was to remain stopped in the shipping lane until mine countermeasures assets arrived from the nearest available platform. A timeline that the 5th Fleet Operations Center assessed at 8 to 14 hours, during which the stopped destroyer would constitute a navigational hazard in a busy commercial lane, and during which the Noor battery might reconstitute its ready missile inventory. The ship moved at 2 knots, the minimum speed at which the propulsion system could maintain steerage without the propeller noise masking the hull sonar's detection capability. 2 knots through a navigational gap that had been identified by helicopter sonar data, and that the hull sonar was continuously re-examining as the ship moved into it. The officer of the deck on the bridge was watching the sonar display, with the specific attention of someone who understood that the next 5 minutes would be spent moving a 32-knot warship at the pace of a cautious pedestrian through water that might contain weapons designed to destroy it. 240 meters of transit at 2 knots, 7 minutes and 12 seconds. The sonar recorded no new contacts in the gap corridor during the transit. The ship cleared the northern boundary of the identified minefield area at 12:59 a.m., confirmed by the sonar operator's report that the contact density ahead had dropped to levels consistent with ambient seabed return, rather than the artificial pattern of a laid minefield. The commanding officer ordered speed to 10 knots, heading north. The mine barrier was behind the ship. The tanker that had been holding south of the threat area, waiting for navigational guidance, was directed through the same eastern gap corridor by the destroyer's navigation team, which transmitted the gap coordinates and the transit procedure. 2 knots, continuous sonar, monitoring. Iranian Noor to the tanker's bridge. The tanker entered the gap corridor at 1:14 a.m. It cleared the northern boundary of the field at 1:31 a.m. 1.4 million barrels of crude oil, through a gap in an Iranian minefield, in the middle of the night, guided by a destroyer that had been shot at while it was stopped in the same gap and that had directed the tanker through afterward. The weapons expenditure for the engagement: 4 SM-2 interceptors for the first missile salvo, 4 additional SM-2 interceptors and 2 ESSM interceptors for the second salvo. Total interceptor cost: approximately $29 million. The mine barrier remained in place across the central lane. Fifth Fleet's mine countermeasures request had been transmitted. The assets were en route. The estimated clearance timeline was 36 to 48 hours. During that time, the established shipping lane was closed to commercial traffic, routing all Gulf tanker transit through an alternate approach that added approximately 3 hours of transit time per vessel and reduced the daily throughput of the commercial corridor by an estimated 12%. 12% of the Gulf's daily petroleum throughput disrupted for 36 to 48 hours by a minefield that had cost the IRGCN a fraction of what the response cost. The mines had not sunk the destroyer. They had stopped it, exposed it to a missile attack while it was stopped, and disrupted the commercial corridor it was assigned to protect. 2 of the 3 objectives had been partially achieved. The Noor battery that had fired was assessed by post-engagement intelligence as having expended its ready magazine. 6 missiles total across both salvos. Its reload timeline was estimated at 12 to 24 hours. It had cost 4 SM-2 and 2 ESSM interceptors to defend against it. The mine barrier had cost the ship 2 hours of its patrol time, helicopter fuel, and the specific stress of a 2-knot transit through a confirmed minefield in the middle of the night, while the crew's attention was simultaneously monitoring for a possible 3rd missile salvo. None of the cost was fatal. All of it was real. The Gulf had found a new way to make presence expensive, not through the dramatic saturation attack, not through the coordinated swarm that demanded maximum interceptor expenditure in minimum time, but through the patient, unglamorous weapon that had defined Gulf naval warfare before the drone era and had apparently not been retired by it. The mines were still there, beneath the surface of the central lane, waiting with the specific patience of weapons that do not need to be operated, do not need to be maintained, and do not need to do anything at all except remain where they were placed until something transiting the lane finds them. The watch continues. So does the waiting.